and today we are going to be talking about sulfur. Now, sulfur is the 16th element on the periodic table, and sulfur has a lot of special properties. Sulfur is often used for its antimicrobial activities and so on and so forth. Because most of your antifungal, antimicrobial, antibacterial cream, they always contain sulfur. So just in case you don't know. So and then we are going to be talking about in chemistry the chemical nature and physical nature of sulfur. Now, sulfur is extracted by the Frasch process, whereby you have three concentric rings. You have your first ring is we have a passage of steam. Then your second ring or the middle ring we have a passage of sulfur. Then the last ring or the largest ring we have a passage of water. And this water water has a very high temperature. So and then this temperature of water is very high, probably like above 100 degrees. So it is pressurized and at a very high temperature, and they are both pushed down into a sulfur deposit. So when it gets there, there's a special type of pump that pumps the sulfur after the sulfur has been liquidized. So it will be pumped the sulfur, and the sulfur will pass through this middle channel. And this is the basics of how Frasch process works. So and then let's move on with uses of sulfur. And there are different uses of sulfur. Sulfur is used majorly for the manufacture of tetroxylate 6 acid. So and then this sulfur is also this acid is also known as H2SO4. And if you've been following my chemistry classes, you would have known that H2SO4 has appeared in many examples. For example, in previous episode we talked about how H2SO4 is a drying agent because it is a hygroscopic substance. And if you've not heard of hygroscopic substance, they are basically substances that are drying agents that can absorb water without getting wet. So and then we also have the liquescent substances, which are substances that absorb water by getting wet. So and there are different types of hygroscopic substances, and those hygroscopic substances, they involve tetroxylate 6 acid. Then the liquescent, you can also talk about calcium chloride. So that was by the way, and that was a digression. So another uses of oxide, another use of sulfur aside from making acid is also for dusting vines to prevent the growth of several fungus. Earlier in this video, I talked about the fact that sulfur has antifungal, antibacterial properties, right? So it's also used for dusting plants to prevent the growth of fungus. Then we also have sulfur is used for making calcium hydrogen trioxosulfate, that's CaHSO4, which is used as a bleach of wood pulp in the manufacture of paper. So you make use of calcium hydrogen tetroxylsulfate 6, yes, CaHSO4. Then you have CaHSO4, the SO3, right? Sorry, SO3 2. So this is also used in the manufacture of paper. So then we also have another property of sulfur is that it is used in the vulcanization of rubber. So and vulcanization is basically a process whereby you apply sulfur to rubber, and it makes the rubber to be strong, because sulfur is kind of like a substance that can attach the linkages of that rubber atoms. So and then the compound by which rubber is made up of, which could be isoprene or neoprene, the linkages between this compound, they are strengthened by the presence of sulfur, and that's known as vulcanization. Then last, talk about another last property of, or rather use of sulfur, which is in the it's used in small quantities for the manufacture of dyes, fireworks, sulfur compounds, and such as carbon disulfide. And carbon disulfide is also a substance that sulfur is soluble in carbon disulfide. So and sulfur is used medicinally in many medicines, just like antimicrobial drugs and creams. So and then let's talk about chemical properties of sulfur. Sulfur has action. Its actions is influenced on the action of heat on sulfur when air is excluded. So when in limited air, when you heat sulfur, there's chemical reaction, and then we have combustion of sulfur in plentiful air. So when you combust sulfur in plentiful air, it forms sulfur dioxide. That is one property of sulfur. Then we also have sulfides of sulfur. Those are compounds of sulfur. That is part of the chemical properties of sulfur. We have acid and sulfur. When acids react with sulfur, for example, tetroxylate 6 acid, when it reacts with sulfur, it produces sulfur dioxide and water. That's one example of reactions. So and then these reactions, they are multiple, but they involve the chemical properties of sulfur. Now let's talk about the allotropy of sulfur. Now, in case you've not watched any episode where I explain allotropy, let me explain to you now. Allotropy is basically the process by which an element or a substance occurs in different physical form but in the same state. So basically this occurs in different forms but it's still the same state. For example, like carbon forms two allotropes which are diamond and graphite. So the properties of that is that they are still in the same physical state but they are in different forms. So now sulfur has two main allotropes which are in the same state but different forms, and that is called rhombic sulfur and monoclinic sulfur. Now monoclinic sulfur is an atom of sulfur that is peculiar for the fact that it has needle-like crystals, while rhombic sulfur has diamond-like crystals, and there are differences. For example, rhombic sulfur is yellow and translucent, while monoclinic sulfur is transparent and amber colored. Rhombic sulfur has a density of 2.08 grams per centimeter cube, while monoclinic sulfur has a density of 1.98 centimeter cube. So, and that is a result of the fact that monoclinic sulfur is stable at a higher temperature, and as a result of that, the higher the temperature, the less the density. That's the general property of solids. Now, next we have the melting point of rhombic sulfur as 114. Then we have the melting point of monoclinic sulfur as 119 degrees Celsius. Then we also have the stability. Rhombic sulfur is stable below 96 degrees Celsius, while monoclinic sulfur is unstable at 96 and is stable above 96 degrees Celsius. Thank you for watching.